In the name of the Vice-Chancellor, we'd like to welcome all of us here to this 415th inaugural lecture of our great university. May I humbly request, therefore, that we all stand for the Vice-Chancellor's procession for this 415th inaugural lecture.
At OAU, utilizing IoT-based sensor technology, the very first initiative of this kind in West Africa. Our research is centered on water and solid waste management within the framework of One Health. She boasts of over 33,507 readers on ResearchGate, 762 citations on Google Scholar, an H-index of 13, and an I-10 index of 17. She's a fellow of Sigma Z and WAPSE, serves as a consultant to EHCON, WHO, and she's a member of various professional organizations including AMS, CSN, IUPAC, IWRA, NES, OWSD, and the Royal Society of Chemistry. She's sadly married to Professor S.S. Okoya, and they are blessed with children and grandchildren. I have this singular honor of introducing to you Professor Aderonke Okoya to present a lecture. Thank you.
Good evening, esteemed guests seated here. Welcome to the inaugural 415th inaugural lecture of Obafemi Awolowo University. The Vice-Chancellor, sir, the Deputy Vice-Chancellor Academic, the Deputy Vice-Chancellor Administration, the Deputy Vice-Chancellor Research, Innovation and Development, the Registrar, the Bursar and the Librarian, Provost of Colleges, Deans of Faculties, and the Student Affairs, Directors of Units, Heads of Departments, Members of Senate, Deputy General Overseer of the New Covenant Church and the Wife, Royal Fathers in the Hall, Members of the University Community, distinguished guests, esteemed colleagues, ECOMSA alumni, and SEARCH research group members, the members of Nigeria Environmental Society, representatives of the Environmental Health Council of Nigeria, ECOP, representatives of the West African Health Organization, representatives and fellows of the West Africa Postgraduate College of Environmental Health, WAPSE, representatives of the Chemical Society of Nigeria, representatives of Organization for Women in Science and Development, distinguished Great Ife alumni, great Obafemi Awolowo University students, Olivet Baptist High School alumni, gentlemen of the press, ladies and gentlemen, I acknowledge the Almighty God, who by His grace I am who I am, and His grace toward me has not been in vain. To God be all the glory. I am also full of gratitude to all who sacrificed their time and money to attend this inaugural lecture. With all my heart, I say thank you. It is therefore with a gladsome and appreciative heart to the Almighty God that I stand before this highly esteemed gathering and with utmost excitement to welcome you as I deliver the 415th inaugural lecture of the Obafemi Awolowo University. To the glory of God, I am happy to state that this is the second inaugural lecture delivered in the history of the Institute of Ecology and Environmental Studies at Obafemi Awolowo University. Coincidentally, it is the first to be delivered by an alumnus of the Institute at OAU. This happened since 40 years ago. It is also on record, Mr. Vice-Chancellor, sir, that I am the first female professor of the Institute and the first female director of the Institute. Thank you. My academic journey. Mr. Vice-Chancellor, sir, my adventure into the field of environment and chemistry started with the opportunity to gain admission to the university immediately after completing and passing my school certificate examination. I entered the university to study BSc Chemistry as a young girl in 1983. The story of my journey of being a graduate of chemistry in the then University of Ife, now Obafemi Awolowo University, will not be complete without the mention of Professor Ile-Ife of the Department of Electrical and Electronics Engineering and the former Deputy Vice-Chancellor Administration of this great citadel of learning. He helped to process my admission offer to chemistry as against my choice of studying chemical engineering at the University of Ife, for which I am grateful and realized that the steps of the righteous are ordered by God. I resumed into the university on the day scheduled for Physics 101 mid-semester test, and that was a day before the matriculation. I can remember how my cousin, Miss Bola Oni, now Mrs. Bola Adeshina, who was in part 2 then, accommodated me temporarily and just told me to drop my bag and go for the Physics 101 mid-semester test without attending any lecture. I did my bit in the test, and the journey continued with a lot of challenges, which I eventually overcame. I am grateful for the toughness of some of my teachers. It has enabled me to stand tall wherever I find myself. The foundation laid by my teachers in chemistry department was a solid one. Professor Ile-Ife Okoya of blessed memory taught me a course titled Organic Spectroscopy in part 3, and I was later on allocated to him as BSc project student in 1987. He laid a very solid foundation for me on how to design and execute research projects. I always remember how he followed me to Ezekiel Oluwasami Library to show me how to look for journals on any desired article that is needed to guide me in my research projects. It was required of me that I make presentation in form of seminar on weekly basis to monitor my weekly progress to him every Friday as an undergraduate. Eventually, I obtained BSc Chemistry in 1987 at the University of Ife. I worked with the Teaching Service Commission for 15 years. After completing my NYSC in 1988, I worked in the Art Service for 15 years. During this period, I got married and raised children with my loving and reliable husband, Professor Samuel Segun Okoya, who took the baton from my parents, Mr. Alfred Adetunji Olubakin and Mrs. Comfort Olawumi Olubakin, and supported me to achieve my goal. In fact, I cherish his faith. When he asked me to begin to write my inaugural lecture before I was pronounced a professor, I smiled. I said, it is only a professor that gives inaugural lecture. But I appreciate his being faithful to his promise to my late uncle, Major Adeola Olubakin, who insisted that I should go for my postgraduate studies. Thank you so much for always holding the fort for me at home during the busy schedules of field and laboratory activities involved in the course of my academic journey. I started postgraduate studies but paused it in 1992 and then resumed in 1996. Professor F.O.I. Ashubioju while PhD was co-supervised by Professor A.O. Ogunfowokan. It is not surprising that I explore researches that utilize solid waste to useful products to attend to environmental challenges, since my undergraduate project topic indicated same. However, I was employed as a junior research fellow at the Institute of Ecology and Environmental Studies while on my PhD at Chemistry Department, OAU. I then rose through the ranks to become professor at OAU in 2021, acting director of the Institute in 2022, and director of the Institute in 2024 till date. In my 20 years of service at OAU, I supervised about 100 postgraduate students and was involved in the training of more than 1,000 postgraduate students at the Institute. In rendering my services, I facilitated the trip of my mentees to attend international conferences and workshops in Europe and Africa through grants from WACREN and ICTP. In research and publications, I have published several high-profile papers in collaboration with my research students and other researchers within and outside Nigeria. Mr. Vice-Chancellor, sir, my major research focus is on water and solid waste management towards One Health. I am profiled at ResearchGate and Google Scholar. Furthermore, I am the principal investigator of the Internet of Things-based real-time surface water project, which is the first in West Africa. 2-year surface water real-time data set of OAU Okpa Reservoir have been successfully archived with the sensors installed, and the project is still ongoing. The data will be helpful to monitor, predict, and enrich the sustainable management of the surface water. This makes OAU to be the first to acquire surface water real-time data in West Africa. I have therefore demonstrated the national and international relevance of my specialty to the development of humanity. I have also been recognized as fellow and honored scientist by WAPSE and Sigma Chi respectively. Sigma Chi is a scientific research honor society in USA, and the award is by nomination and voting. I was unanimously voted for during the nomination. I am also recognized as consultant for Environmental Health Council of Nigeria, Federal Ministry of Environment, and West African Health Organization. I am a member of many national and international professional bodies in my profession. This journey could not have progressed to this level without the support of my supervisors and the solid foundation laid by all my teachers in chemistry. I want to put on record also the contributions of Professor A.A. Amusha and Professor Duro Yedele of Department of Soil Science, Faculty of Agriculture, during the field aspect of my master's degree. I am grateful to Professor Nelson Toto for the award of SINAC Fellowship and his research group members, including Professor A. Akinlua, as a research visitor at the Department of Chemistry, University of Botswana, Gaborone, Botswana. I want to put on record the contribution of the following Destiny helpers: Professor Michael Faborode as the Dean of Faculty of Technology, Professor I.F. Adeniyi, Professor A.A. Adedina when he was DVC academic, Professor A.O. Isiche, Professor O.O.I. Orimogunje, Professor Lubola M. Babalola, and Professor A.S. Bamire when he was the Deputy Vice-Chancellor and now the Vice-Chancellor chairing this inaugural lecture. The journey is very long, rich, eventful, fruitful, and worth it. Introduction. Mr. Vice-Chancellor, sir, distinguished guests, ladies and gentlemen, the beginning of life in our planet has always been a function of water availability. Although water may seem abundant, only about 2.5% of Earth's water is fresh water, out of which 0.3% is available for plants, animals, and humans' use. The rest is frozen in glaciers and ice caps or too far underground to be accessed. The accessible water to humans is often used in an unsustainable manner. Water pollution is therefore caused by the introduction of any substance into the water that makes it unfit for the intended use and also cause hazard for the user. Over the years, our use and misuse of water, a vital resource to quality living and survival, has surprisingly altered the important information it carries. Water may appear clean or colorless, but it could have pollutants that are invisible to ordinary eyes, and that is their secret life. Hence, the title of this 415th inaugural lecture, Managing the Secret Life of Waters for One Health, a Waste to Wealth Approach. One Health is a collaborative, multi-sectoral and transdisciplinary approach with the goal of achieving optimal health outcomes, recognizing the interconnection between people, animals, plants, and their shared environments. For example, the way land is used can pollute water resources, and if not treated to meet the specific needs, can impact a number of diseases in human, animals, and plants. The most basic effect of water pollution is directly suffered by the organisms and vegetation that survive in water, including amphibians. On a human level, several people die each day due to consumption of polluted water. The runoff that drains directly into the receiving water bodies without any treatment contributes to surface water pollution. The most recent Environmental Protection Agency information places urban-related runoff with 9th in the probable sources of contamination to our rivers, streams, and lakes. Consequently, polluted runoff contaminates the water we use for drinking and recreation and can have adverse effects on humans, wildlife, and plants. For example, bacteria and other pathogens can wash into water bodies, causing health hazards for both humans, animals, and plants, amongst others. The theoretical framework. One Health, according to World Health Organization, is an integrated, unifying approach that aims to sustainably balance and optimize the health of people, animals, and ecosystems. It is a collaborative, multisectoral, and transdisciplinary approach, working at the local, regional, national, and global levels with the goal of achieving optimal health outcomes, recognizing the interconnection between people, animals, plants, and their shared environments. There is therefore need to go through some specific terms like adsorption in our study. Adsorption is the concentration of a solute at the surface of a solid. This phenomenon takes place when such a surface is placed in contact with a solution. A layer of molecules of solutes accumulates at the surface of the solid due to imbalance of surface forces. In the interior, molecules are completely surrounded by similar molecules and therefore subjected to balance forces as indicated in the diagram. The core discourse of my research: method development for the removal of organic and inorganic pollutants from industrial wastewater using solid waste and molecularly imprinted polymer-based adsorbents. Wastes are generated from different homes, offices, healthcare facilities, industries, and from various agricultural activities in large amounts, which are disposed of to various landfill sites. These wastes are therefore grouped into residential, commercial, industrial, institutional, construction, and demolition area, municipal services, biomedical, and agricultural waste based on the sources. There are several ways of classifying solid waste. It can also be classified according to whether it is biodegradable or non-biodegradable. Biodegradable solid waste are those that can be decomposed or broken down into their constituent elements by the actions of bacteria and other microorganisms. Examples include food waste, manure, and some agricultural waste. Non-biodegradable waste are those not decomposed by microbial actions. They are sometimes referred to as inorganic waste. This waste can be generated from plastic containers, scrap metals, food and drink cans, plastic bags, and so on. Our research focused on conversion of both the degradable and non-degradable waste, which poses potential threats to public health and the environment, to useful products for different industrial applications. The need for solid waste utilization to solve pollution problems in Nigeria. The current state of waste management in Nigeria is of major concern due to the high rate of waste generation and poor management practices. Nigeria produces an estimation of 32 million tons of solid waste per year, with only about 20 to 30% of it being collected and managed correctly. The remainder of the waste is either dumped in unauthorized places or burned, contributing to pollution of the environment, including water bodies and the associated health risks. Nigeria produces the most solid garbage in Africa, with approximately 70% of it being plastic waste that winds up in landfills, water bodies, or sewers. According to the World Bank, Nigeria is the 10th largest producer of unmanaged plastic in the world, accounting for 2.7% of the global total. Nigeria, therefore, will generate the most unmanaged plastic waste in Africa by 2050. Driving over bridges that overlook aquatic bodies in Nigeria is an eyesore because plastics and nylons are visible. In some parts of Nigeria, the odor emitted by waste renders those places unfit for habitation. The dump sites in Nigeria breed mosquitoes, resulting in a high incidence of malaria, as well as a high risk of contracting cholera and other diseases. Waste disposal and management have a direct effect on climate change, and appropriate waste disposal and management are critical components of any climate protection policies and actions. Our research output will aid in the development of a more sustainable and resilient Nigerian economy, while also supporting One Health through the production of useful products from agricultural and other industrial solid waste for the production of improved quality of water supply and treatment of industrial wastewater. My research focus is therefore a multi-dimensional approach of solving environmental problems towards One Health through solid waste management, wastewater treatment, and water supply and sanitation using adsorption techniques. The list of waste that have been converted to useful products, especially in the treatment of both water for domestic uses and wastewater from different industries before being discharged into the different water bodies, are presented in the table. The table shows different solids which usually pose management challenges that have been converted to useful products through our research outputs. Caustic alkali is a raw material for many chemical industries. For instance, alkali has been successfully extracted with improved aesthetics from cocoa pod husk, which is a solid waste from agricultural industry generated from cocoa processing factories. The carbonate salts obtained compare well with in quality and quantity with the imported alkali used in chemical industries and even as laboratory reagents. Also, adsorbents have been prepared from different biodegradable waste such as maize husk, coconut husk, rice husk, sawdust, cocoa husk, and non-biodegradable waste such as bottles and nylon bags made from polythene, styrene, polyethylene, terephthalates, snail shells, periwinkle shells, amongst others. Our methods have been developed to use these adsorbents in form of activated carbons and imprinted polymers for the removal of different pollutants from organic media, such as crude oil, aqueous media, especially in the treatment of wastewater and water supply. Also, the useful products are also being utilized for different purposes in different industries. The conversion of this waste to useful products can improve the aesthetics of the environment, improve human health, and save the country from some of the problems associated with foreign exchange. The research activities can also spring up small-scale industries to create jobs for the unemployed Nigerians if exploited. Adsorption of selected inorganic pollutants using solid agricultural and industrial waste-based adsorbents. Rapid increase in industrialization has led to increased disposal of both inorganic and organic pollutants such as heavy metals, dyes, pesticides, residues, hydrocarbons into the environment. The major inorganic pollutants of focus in our research are heavy metals concentration and levels of physicochemical parameters. With the vision to turn waste to wealth and at the same time managing our water resources and supply, I examined the absorption of heavy metals from aqueous solution using agricultural waste generated from agricultural industries in Nigeria to remove heavy metal pollutants. Agro waste are vast abundant raw material whose potential is still underutilized in Nigeria. Availability and biodegradability are a few features of these materials for utilization. At this point, it will be necessary to run through an example of such applications in which agro and industrial waste were developed into adsorbents to remove metals in aqueous media. Cocoa husk and polyethylene terephthalate, PET bottle, our Coke bottle that we throw around, were developed to alkali activated carbons used to remove heavy metals from cement industry effluents. The cocoa husk used to produce caustic alkali using the method were obtained from the Obafemi Awolowo University Teaching and Research Farm, while the PET bottle waste were gathered from waste bins in Ile-Ife, Osun State. Activation of PETs utilizing analytical graded KOH and the cocoa husk alkali produced from cocoa husk, which was earlier used for hydrolysis reaction, were carried out. This was done to compare and validate the quality and suitability of the alkali being used to activate carbon for adsorption studies using the procedure outlined in our research. The alkali activated PET samples were then carbonized. Surface properties and physical morphologies of the activated carbons by scanning electron microscopes were carried out, and it is shown in the figure, which depicts the subsurface morphology prior to the adsorption processes and after the adsorption processes. However, following adsorption with the effluents, upstream and downstream samples, the pores displayed by the adsorbents have reduced drastically, and which may be a result of heavy metals blockage, indicating that adsorption had occurred. Elemental composition of the activated carbons before and after adsorption. The elemental composition of the alkali PET activated carbons was determined both before and after adsorption using scanning electron microscope coupled with an energy dispersive X-ray. For CAP, the result demonstrated that carbon has the maximum percentage As stated, for cement industry effluents upstream and downstream, the receiving water body after adsorption with CAP and KOH PET activated carbons respectively. This makes the alkali PET activated carbons suitable for adsorption. Determination of metal concentration using ICP-OES. The heavy metals concentration of the cement industry wastewater was determined using inductively coupled plasma optical emission spectroscopy to evaluate the concentration of the metals in the wastewater before and after adsorption with the cocoa husk-based activated PETs and the analytically graded KOH-based activated PETs using the optimized conditions obtained from simulation experiments. The PET has worked as a precursor for the manufacture of activated carbon with alkaline filtrate from cocoa husk, serving as the activating agent according to the findings. The activated carbon formed could be used to remove metals from wastewater as an adsorbent. For the best adsorption conditions are stated, and 0.25 grams adsorbent dose was used respectively. According to Langman and French-Louis adsorption and models, C-PAT and K-PAT have been found to be effective for the adsorption of heavy metals from cement industry wastewater. The solid waste, PET and cocoa husk will then not be a nuisance to the environment, but managed and processed into useful products. Our research also considered the efficacy of Moringa oleifera seed and seed husk as adsorptive agents for water treatment. Health-related and environmental side effects associated with conventional chemical coagulants used in water treatments has prompted the search for natural alternatives, especially of plants origin. Moringa oleifera belongs to the Moringaceae family. Although considered a non-indigenous species, it has found wide acceptance among various ethnics in Nigeria and many other countries, and is being exploited for different uses such as food, medicine, fodder, and recently in water purification. Water treatment with Moringa oleifera crude seed extracts have low shelf life due to increase in organic loads. Hence, isolation of the active coagulating agents becomes imperative. In the light of this, we carried out a study which investigated the water coagulation activities of a purified protein from Moringa oleifera seeds on the water from Obafemi Awolowo University Ile-Ife. Moringa oleifera coagulant protein was purified via ion exchange and gel filtration chromatography respectively. The study concluded that Moringa oleifera coagulant protein has shown biocoagulation activity, which is an exploitable property, since the water quality parameters treated with the protein met most of the Nigerian standards for drinking water quality. The results of the antimicrobial activities also indicate that the biocoagulant has the potential to be used as a biodegradable active ingredient in water disinfection. However, despite all these benefits, natural coagulants should be effectively applied to the process of water coagulation and treatment in scale only after undergoing tests certifying their non-toxicity, biodegradability, and viability. The exploration of Moringa oleifera seed as coagulants and for removal of contaminants from water, amongst other uses, has led to the increasing demand for Moringa oleifera plant for different purposes, and also simultaneously led to the generation of waste, such as the seed husk. Also, water treatment is necessary in this age of burgeoning human population and high demand for water resources, and water reuse has surfaced in both urban and rural areas. Potable water is becoming a scarce commodity, and the treatment of available water with disinfectant for domestic water supply sometimes leaves disinfectant byproducts such as trihalomethanes. Trihalomethanes have been found to be the most widely spread organic contaminants in drinking water, and they are carcinogenic and sometimes mutagenic when ingested in high quantity. Trihalomethanes are formed when excess chlorine during chlorination of water reacts with organic material in water. Moringa oleifera has found wide acceptance by many people in Nigeria who have used it for food for both humans and fauna, for health purposes, and as a coagulant for water treatment. However, the seed husks are currently discarded as waste, and our research found out that there is a paucity of data on the use of Moringa oleifera seed husk for the removal of trihalomethanes from the aquatic environment. Therefore, in another study, the absorption efficiency of mulch activated carbon for the removal of trihalomethanes and to evaluate the efficacy of mulch as a coagulant for water treatment was assessed. The physicochemical properties of both the treated and raw surface water were determined using standard methods, and the concentration of trihalomethanes in water samples at different stages of treatment of the water treatment plant was determined using gas chromatography with flame ionization detector as presented. Recovery experiments were carried out To validate the procedure, physicochemical property of the activated carbon of Moringa oleifera seed husk adsorbent was determined and characterized using scanning electron microscope coupled with energy dispersive X-ray analyzer to determine its elemental composition before and after adsorption experiments. The efficiency of the characterized activated carbon for the removal of trihalomethane in the water and as a coagulant for water treatments were also assessed. Batch adsorption experiments were carried out and different parameters were optimized for the removal of trichloromethane and tribromethane using the Moringa oleifera seed husk activated carbon. Experimental adsorption data from different initial concentrations of trichloromethane and tribromethane were used to test conformity with adsorption isotherms. The mean percentage adsorption efficiencies were encouraging and it ranged from 34 to 93 and from 41 to 94. The optimum conditions for both trichloromethane and tribromethane were pH 9, 0.8 grams adsorbent dosage, 60 minutes contact time, and 0.6 milligram per liter initial concentration. The optimum values of these parameters used for the adsorption of the two trihalometanes in the surface water serving the treatment plant gave an efficiency of 100%. The experimental data best fits into lag more than phenolic adsorption isotherm. The study concluded that concentrations of 0.5395 and 0.5725 milligram per liter, as well as 0.255 and 0.288 milligram per liter of trichloromethane and tribromethane were present in the raw and treated water, respectively. The optimum conditions that gave the highest efficiency for both trichloromethane and tribromethane in this study are as presented and can be used as coagulant for water treatments. The molecularly imprinted polymers as adsorbent for the removal of organic pollutants. Molecularly imprinted polymers are characterized with selective binding sites for a template molecule of interest. Our research therefore explored this method to remove polyaromatic hydrocarbons such as pyrene from domestic water supply, bromochrysone green and malachite green from textile wastewater, and from crude oil. Polystyrene was developed to complement conventional water treatment methods for pyrene removal following the processes in the graphical abstract being presented. Bulk polymerization was used to synthesize pyrene, imprinted polystyrene, and its non-imprinted analog. Monoliths were characterized using SEM-EDX, FTIR, and XRD. Extraction and concentration of pyrene were determined using GCMS. Adsorption experiments on simulated solutions of pyrene with different concentrations, pH, adsorbent dosage, time, and temperature using PIP and NIP with equilibrium studies were done. Recovery was performed while pyrene was adsorbed using simulated experiments best conditions. Used PIP and NIP were characterized. Pre-adsorption characterization confirmed PIP and NIP, while post-adsorption showed a clogged surface for NIP, but PIP was pyrene selective. Pyrene concentration in the domestic water supply was greater than WHO standard of 0.0002 milligram per liter with 100% recovery. Adsorption efficiencies range from 25 to 100% and 15 to 100% with varied parameters of PIP and NIP respectively. However, best adsorption conditions are pH 9, time 60 minutes, adsorbent dosage of 0.8 grams, and concentration of 0.001 milligram per liter, and temperature of 27 degrees centigrade, which means that experiments can actually be carried out at room temperature. Challenges and opportunities in environmental sciences for One Health. All said and done, there is a need for regular monitoring of the impact of pollutants on the environment. Our systematic review in the field of environmental health sciences in some African countries documented the challenges and opportunities by examining published work with a specific focus on Africa. The reports showed that funding and infrastructure are the major problems. The study also highlighted recruiting study participants, retention, and compensation as a bane in the field in Africa. The absence of modern equipment also hinders research. The review, however, noted research collaboration from the region, including studies on emerging pollutants such as pharmaceuticals, PFAS, and microplastics as great opportunities. The study concluded that collaboration with other continents, exchange programs, and improved governmental interventions may help. An attempt to handle some of these challenges was made by our team, especially with respect to the water resources management in the developing countries, including Africa. Many developing nations struggle with water monitoring approaches, as data collected are often not timely for any treatment or intervention necessary to make water safe for different uses. a report of an IoT-based approach for timely water quality assessment, especially suitable for unique challenges of developing countries, was presented by our research group. The paper presented a cost-effective Internet of Things-based approach to water quality monitoring, specifically designed to meet the needs of developing countries. As the first of its kind in Nigeria and arguably Africa, we are proud to announce that 2 years surface water data of Opa Reservoir in OAU has been archived and presented for publication. This clearly illustrates the system's efficiency and potential for delivering timely insights into water bodies and reveal the secrets early enough for water quality monitoring and management. The study is a result of the multi-institutional collaboration involving the International Center for Theoretical Physics and in Italy and the Swatch Research Group at Obafemi Awolowo University Institute of Ecology and Environmental Studies, Ile-Ife, Nigeria, and the West African Central African Research and Education Network. The study is being extended to other countries to date. My contributions and professional accomplishments. Mr. Vice-Chancellor, sir, I joined the services of this university as a junior research fellow on the 6th of March 2006. Rose through the ranks to be pronounced a research professor in March 2024, backdated to 1st October 2021. Furthermore, I was appointed the acting director of the Institute of Ecology and Environmental Studies on the 1st of August 2022 till 31st July 2024, and later appointed as director of the Institute in 1st August 2024 till date. During my tenure, the staff strength increased by 6, 1 research fellow 1, 2 research fellow 2, 2 junior research fellows, and 1 administrative staff. This has really enhanced the quantity and quality of our activities and delivery to time. In my 20 years of diligent service, I have supervised many postgraduate students who are excelling in their public and private sectors. In view of the need to enrich the exposure and training of my project students, I facilitated the trip of some of my students to attend international conferences and workshops in Europe and Africa, and some are still going after this inaugural. In the course of the supervision of these students, I have been able to ensure that a good number of my students is practically exposed to how to produce useful products from different raw materials, which are mostly solid waste, and taught them the art of publishing using data generated from these researches. The knowledge acquired can be a source of income for them if they are able to put them into practice and market their products. As a researcher, I have documented and published the concentration of organochlorine pesticides contents of 11 rivers in cocoa-producing areas of southwestern Nigeria. Also, some agricultural and thermoplastic polymer waste in Nigeria have been identified and processed into adsorbents as earlier presented for the removal of organic and inorganic pollutants in the treatment of water and wastewater with the method developed and optimized conditions established. Production of these adsorbents using solid waste in our environments has also contributed to the management of solid waste. I have presented at conferences and published the results of the research activities in countries representing different continents such as Africa, Europe, America, and Asia. In fact, during one of the visits to ICTP, the IoT project was established. Mr. Vice-Chancellor, sir, this makes Obafemi Awolowo University to be the first to acquire such in West Africa. You were magnanimous, sir, to receive the workshop delegates from the different countries, from Ghana, from Ethiopia, Italy, South Africa, Cote d'Ivoire, to mention a few, for the commissioning of the installed sensors, and you were well represented at the commissioning by the management team led by the then Deputy Vice-Chancellor Academy, Professor Mobola Babalola, and Professor Akani Akinyemi, DVC Research, Innovation and Development. Also, the Institute of Ecology and Environmental Studies celebrated our 48th anniversary on May 31st to June 8, 2023, under the chairmanship of Professor Michael Faborode, with dignitaries from home and abroad in attendance. The event featured a waste-to-wealth training workshop by a UN facilitator, health safety and environment training by a United Nations trained resource person, and an international conference with the theme Ecosystem Restoration and Implication for One Health. The Institute also inaugurated our Alumni Association and held its first reunion program. My achievement as director includes the general rehabilitation of the Institute building, which includes replacement of 33 termite-destroyed wooden doors with metal doors, repair of the roof and ceilings, purchase and installation of water tanks and other plumbing repairs, amongst others. Mr. Vice-Chancellor, sir, other fellowships and research grants awarded to support our research activities includes award from CNAC, Carnegie, Tech Fund Research and Travel Grants from ICT, WAO, and WACREN at multiple times. In addition, I have also given a number of public presentations at conferences and workshops within and outside Africa. My academic-related services are not limited to my researches, teaching and supervision of students, but also includes other services within and outside the university. In addition to being an internal assessor of professorial cases in OAU, I have serving as external assessors of cases of promotion to professor cadres at different universities.
In addition, I have served as professional examiner for the Governmental Health Council of Nigeria at different universities and external examiners of candidates for the award of LSC affiliated degrees at different universities as well. I also delved into some non-academic related activities which benefit the community at large through my involvement in the alumni association of this great citadel of learning, where I was federal/national secretary at the branch and national levels of the association. I was a member representative of Nigeria Global Award Committee. Yes, these experiences were great and interesting. Implementation and future outcome. Mr. Vice-Chancellor, sir, my research has involved a multifaceted approach to document the common solid waste in Nigeria, which constitute nuisance to our environment because we did not find sufficient and sustainable use for them. The approach has highlighted a number of products that this waste can sell as raw materials for their production. The products, in addition to being used in the water treatment industry, also find ready use in different industries as raw materials for other products. For example, nitrogen and activated carbons produced for some of the waste around are not only useful for water treatment, but are also useful in the medical industry. Also, keratin and caustic alkali are part of the component of soap production, and this gives them relevance in the cosmetics and soap industries, amongst others. In the light of this, research in this area should be sponsored to the point of precision for commercialization for better improvement on treatment of wastewater as well as other industry uses. This will enhance the national economy as many small-scale business investors will prioritize bulk manufacture of these products. The government developed an assembly of interest investors who can produce them on that scale for household and industrial uses. Apart from the usefulness of the surface water pollution sector data obtained from our research results, the baseline data obtained will be used for environmental impact assessment of industries to be located in such areas in the nearest future. Government and households can make use of our findings to improve the conventional water supply treatment facilities in line with Sustainable Development Goals 3, 6, and 12. The products of these researches have relevance in both local, national, and international development. Conclusion. Mr. Vice-Chancellor, sir, please permit me to summarize the story of the young girl to encourage some young minds in the area. Once upon a time, there was a little girl who was enrolled in primary school by her parents of President Simeon, who are members of the education and gave their best to lay a foundation, a solid foundation for her. Every day of the year gathering, her dad would come and witness the celebration because the girl was 2 years. She died thereafter, drive back to the bookshop and buy all her books. Unfortunately, the dad died when she was in primary 4. The girl and her mom had to sweat it out to survive with her 4-year-old junior brother. This made the girl, in addition to her study, to hawk books on the streets. She eventually completed her secondary education and immediately gained admission to the university. She was one of the 4 out of 40 admitted students in her set to graduate for record time in the department. To cut the long story short, the girl walking on the streets to support her mother for survival is a professor researching in the program. All the parents have come to wait for me, and of course my family. To the young ones in attendance, whenever you are directed or guided to be visited by your parents, teachers, or anyone in or whatever you lay your hands on, remember it is for your own. Also, God says to bless the works of your hands. However, if for any reason you not lay your hands on anything, that is zero, and God blesses you with millions and it remains zero. If you still remain zero. On the other hand, if the work of your hands is not zero, but greater than zero, and God blesses the million times, your benefit will change from 1 to 1 million or more, depending on you. Diligence is therefore not only about pains, but it is accompanied by much gains through the multiplicity factor of God. Diligence is godliness based. As technology. Who at one time or the other has founded that we circular financial impact of treatment value of BPSS. The contributions of all members of academic technology and advanced part of the institute are thereby placed on record. I especially appreciate the members of my research group, the Square Research, and those of them are busy around in Nigeria and diaspora. In fact, this presentation is for the bunch of the loyalty of my research in the face of uncertainty, doggedness, compliance, and readiness to promote all mandates. Sincerely celebrate. To my caring parents of present memory, Mr. Adetutu and Mrs. Dr. Obafemi, who are members of the delegation to our forever cherish and the memory being from. To my loving, ever supportive and understanding children by birth and by marriage and by academic, as well as my other family members by blood, by marriage, and the my family of God, I celebrate you, I love you, and I appreciate all your support that you give at all times. You are the best. To my very many friends from the University Secondary Primary School and Professional Associates, I say thank you all, and have a safe trip to your destination. Finally, to my very own best friend, my darling husband, Professor Simeon Okoya, seated and smiling there. I want to tell you that you are a special gift, especially gift for me, to keep you. I know my appreciation more than anybody expression. You are my dear one, my personal person, my friend, my grandmother, my wife. By the grace of God, nothing shall separate us. My interaction with every particular of you have not been many lessons of life at all. Any though I get of independence, any problem I'm facing is teaching me how to get solutions to problems. Any account I get from people is teaching me the best form of friends. Any money or abandons me is teaching me how to stand up on my own feet. Life is not measured by the amount of money, houses, or companies you have, or positions of life, but by the positive impact you have made in the lives of others. Mr. Vice-Chancellor, sir, and this highly esteemed audience, I thank you for your time.
certificate presentation. Obafemi Awolowo University certificate of presentation of inaugural lecture. This certifies that Aderonke Okoya, a professor of environmental chemistry, environmental management in the Institute of Ecology and Environmental Studies, Faculty of Science, Obafemi University in Nigeria, delivered the 415th inaugural lecture titled Managing the Secret Mind of Waters One Health, the Waste to Wealth Approach. Today, March 10th, 2026. Congratulations.
I have permission of the Vice-Chancellor to invite the Council of Research to join me this morning. Please get back down. Thank you.
What's the level of staff? Congratulations.